Hello. Today we're going to learn one of the concepts about time value of money, specifically simple versus compounding interest. It's important to note the time value of money means that the money that you invest today, and if you earn interest on it, it will grow to a larger dollar amount in the future. The time value of money concept has nothing to do with the worth or buying power of the money or the dollars. So for example, if I invest $100 today in the bank and then I earn 6%, then in a year from now I would get $106. The difference between the $100 and 106, that's $6, that is the time value of money. The worth or the buying power of the money doesn't have anything to do with the time value of money. Because let's just take the $100 today. $100 today could, for example, buy me an outfit with a shirt, jeans, and shoes. However, if inflation is higher today than what it is, then maybe the $100 would only afford me a shirt and jeans. That has to do with the inflation and the worth of the dollar. The time value of money is the difference between the dollars that you have now and the dollars you have in the future because of the interest earned. We use the time value of money concept in accounting as well as finance, and it's used in a variety of ways when we deal with assets and liabilities and revenue and expenses, which we'll get to in intermediate part 2. Let's talk about simple versus compounding interest. Interest is the amount of money paid or received in excess of the money that you borrow or lend. Interest is a concept that we should all be familiar with because most of us have a credit card, which means we are borrowing money from our credit card, and that doesn't come free. It comes at a cost, which is the interest that we end up paying. There's a concept called simple interest, and that just means you take your initial investment, let's just say it's $100, and let's say we have 6% for 1 year, then we get $106 at the end of the 1 year. That's simple interest. I think we're all pretty familiar with that kind of computation. Compound interest means that you also either pay or earn interest on the interest. You earn money on the initial investment, but also on the accumulated interest that you earn in previous periods. So here's a quick example of the simple interest. And then let's just move on to the compound interest. Suppose you invested $1,000 in an investment account paying 10% compounded annually. How much interest will you earn in each how much interest will you earn in each of the next 3 years, and what will be your investment balance after 3 years? I just want to quickly actually go back to simple interest calculation, which was we invest $1,000 at 10%, we earn $100 interest. That's a simple interest. So we would have $1,100 at the end of that year. Compound interest says, let's take my $1,000 that I begin with, right? And I take my 10% interest times 1,000 is $100, right? Right here. And then for year 2, I would take my 10% and multiply it by that $1,000 plus the $100. So this is plus 100, right, equals you 1,100, and that's what you compute your interest on, and that equals to 110. So then you take the 1,100 plus 110, and that gives you 1,210, and that takes you to year 3, and you take year 3, you multiply by 10, and you get $121. And so in total, you earned $1,331. Let's look at the difference between when interest compounds annually, which means once a year, versus more than just once a year. So here in this quick example, we have where we have $1,000 and we get interest once a year, 10%, so that's $100. And so the end of the year one, we have $1,100. And then, so this is compounding, so we get interest on the principal plus the interest we have already earned. So here in year two, we have $1,100 times 10% gives us an interest of $110. And so this $1,210 at the end of year two. And then end of year three is $1,331, which we've already gone through. Now let's see what happens when we compound semi-annually. So that means 2 times per year. So we still start with our $1,000 right here. And just note that instead of getting paid 10%, since we're getting paid twice a year, we have to we say, okay, we don't get 10% twice a year, we get 5% twice a year, which equals 10%. So you take your 10,000. So we're going to take our $1,000 times 5%, gives us $50, and we add that to our $1,000 to get to our $1,050. So that was on June 30th. On 12/31 we get the $1,050 times 5% equals 53, and then we get 1,103. So you notice that we have now 6 periods where we receive a payment, or we accrue interest, I should say. And so on June 30th and 12/31 for each year going to 12/31x3, and at the end of the year of 12/31x3, we have 1,340, which is more than $1,331. Continuing on, if we decide to compound quarterly, it's the same math, except now my 10% has to be split into 4 periods because we accrue interest 4 times a year. So now I look at my I have here for March 31, 6/30, 9/30, and 12/31 for each year, and I compound my interest. And so when I get to the 12/31x3, my total that I've earned is, the total I have is $1,345. So I've earned $345 of interest over a 3-year period. So you can see here I've earned 331, here 340, and this is $345. So the more frequent you compound, the more money you will earn. So this slide just tells you that if you're earning 12%, you see you're going to earn more. In the year one, you're earning 12% straight. In year two, you're actually, when you do the math, you're ending up earning 12.36%. And for the more frequently your payment is compounded, the more you earn. So your effective rate is higher. So this is your effective rate, even though the terms are 12%, but because it's compounded more frequently, the effective rate goes up. So assume that you invested $1,000 in an investment account paying 10% interest compounded twice a year. What will be your investment balance at the end of the first year versus, and what is your effective annual interest rate? So here, because we're compounding twice a year, we have 2 periods a year. So we have to cut our interest rate that we earn in half, or divide by 2. And we end up getting, at the end of year one, we end up getting $1,102.50, giving us an effective annual rate. We earned $102.50 on our initial $1,000 investment. Our effective rate is 10.25%. Quick check. Jacob Lee invested $600 in a savings account, paying 8% interest compounded twice a year. What will his investment balance be at the end of the first year, round to the nearest dollar? So you can hit pause and do the math. right now. And hopefully you got the answer is $649. And this is how it's calculated. Don't forget that because this is compounded twice a year, oops, this is compounded twice a year. Let me just go back into my slideshow presentation. That your interest rate gets cut in half. That's really, really important. But your total end of the year, what you earned is $649.